I think the hardest thing about a physics problem is it's like you have to like choose equations, and you have to keep solving things. It's not I'm going to plug in some numbers into one equation and that'll give me an answer. It's more like, okay, in order to solve this equation, I need to find this value. So then you got to have a separate equation for that value. It's really about systems of equations. That's why it's super helpful to like draw the picture and then label what you know and label what you don't know, because when you see it in front of you, you go, oh, I can find the time if I use this equation. I can find the distance if I use this equation. Or I could use this equation, but I don't know the time. Oh, but I can find the time if I do this. And that's the hard part, because you have to make a decision. And because you guys are learning it, you don't have all the equations in your head. So it takes a little longer. But this one says a projectile has an initial velocity of 26 meters per second. The projectile and the x component velocity is 5.3. The exponent and the y velocity is 25 meters per second. So what they're saying is I have, whoops, I did that wrong already. I have the x component of this velocity is 5.3 meters per second. So that's the velocity, that's the initial velocity in the x direction. Then it has a y velocity, which is much bigger, at 25 meters per second. And that's the initial y velocity. And then there's, of course, a resultant vector of that. And that's this thing here. And that's just the initial velocity, and that's equal to 26 meters per second, okay? And so somewhere down here, there's a, I don't know. We don't know what the projectile is. We'll just assume it's like a, I don't know, cannonball or something, right? So we know what it's going to do. It's going to make a parabolic shape, and it's going to shoot across and land somewhere over here. All right? So it's going to shoot somewhere across and land over there. And it's going to do that. There are a lot of assumptions we have to make. It doesn't say anything about it being shot from a height or anything like that. So we're going to assume that it's on level ground. Right? In other words, this is being shot and will land on level ground. And if I scroll up a little bit, we could also assume that the initial x position right here, in other words, this position right here would be our final x position, okay? And we don't know what that is, but we know that the initial x position was 0 meters. And it's asking us for the range. Well, the range equation is delta x is equal to, and there's two of them. I like to use the short one. Okay. Of 2 theta. Okay. All over the acceleration due to gravity on Earth, which is 9.8. Okay. And there's usually like a negative and a negative, but the negatives cancel anyways. Just leave it like that. I need to know what theta is. So remember, this right here, let me move my face. This right here is literally labeled the range equation. All right, so this is one of those scenarios. Well, oh, I need the range. Oh, the range is great. I just got to calculate it. And I go, well, I know the initial velocity, it's 26, but I don't know theta. So then I got to go in my notes and go, well, how do I find theta? Does anybody know how to find theta? Well, remember that theta is equal to arctan of the y component. So in this case, it would be Vy0 over the x component, which would be Vx0. Or another way to think of it is, if you want to think of it in geometry terms, this is the hypotenuse, this is the opposite, and then this right here would be the adjacent. So remember with SOHCAHTOA, tangent, bless you, of theta is equal to the opposite over the adjacent. That's why we have the y on top and the x on the bottom. Whatever works for you. So then to find theta, I just need to come in here and say, what is the arctan in degrees of 25 divided by 5.3? Oop, got to move my face again. Had a vitamin water break. All right, so in Desmos, you just click on arctan right there. And then we're going to say 25 divided by 5.3, right? And do make sure that you're in degree mode, because if I do this, it gives me a different number. Do you see that? This is radians. That's how many. That's the measure of the angle in radians. This is the measure in degrees. So it's about 78 degrees, right? Roughly. Okay. So let's write that down. Theta is approximately 78 degrees. All right. So now we just plug that into the formula. So then my delta x, the range that it travels, is v squared, but v naught is just 26 meters per second. So that's why they gave us the x and y components, so we could figure out the angle. So we would say 26 squared times sine of, in parentheses, 2 times 78 all over 9.8. Okay. I'll leave that up there for a second for you to write that down. This is 2 times 78. All right, going to Desmos. Let's clear this out. I'm going to say 20. Oh, wait. I'm going to do my fraction up here. When you do stuff in the calculator, it's always better to put the fraction stuff in parentheses. So I'm going to say 26. You don't have to, but I like to. Times sine of 2 times 78. Close parentheses, divided by 9.8. Okay. So my answer that I got was about 28. They did some rounding. So the solution that you have, so let's just finish that. So then I ended up with delta x is about 28 meters, but on the, I'm looking at this now, they did some rounding because they used the other formula and they rounded for sine and rounded for cosine. And so they have about 27.5. Right, so I think that's one of the options. our answer is more precise than theirs. So technically they have a rounding error. But if you were to round it up, it'd be about 28. So, yeah, what? Oh, does it say 28? Okay. I like the double, because sometimes I make mistakes. So I have the solution over here, and I'm looking at it. I was like, it's not 27.5. But then I looked, they did sine and cosine, and then they rounded their values for sine and cosine, which makes a little bit of a difference. You should never round in the middle of the calculation. You should wait till the end and then round. Yes. Yeah. Let me zoom out so you guys can see the whole thing. I don't know if that helps or makes it worse. All right. I'll leave that up there so that you guys can finish